Now, for some of the Group 7 questions, I've had to turn to AS papers. It's mostly learning, to be honest, but there's not that many A2 questions on there, but we know this year there will be. AS paper 1, specimen 1. Questions about chemical properties of chlorine, sodium chloride and sodium bromide. Write an equation for the reaction of sodium bromide and explain why bromide ions react differently from chloride ions. So what you need to do is you need to have done your learning and realise that the overall equation for sodium bromide, Na2Br plus 2H2SO4 goes to form bromine. We know that water and sulfur dioxide and sodium sulfate from the first reaction. So if you can remember NaBr plus H2SO4 and you can remember the products, bromine, water, sulfur dioxide and sodium sulfate, you should be able to write that and balance it fairly easily. Why Br minus are oxidized by sulfuric acid? I said on the introduction that's because Br minus are bigger than Cl minus and therefore Br minus are more easily oxidized, or you could say lose an electron more easily. A colourless solution contains a mixture of sodium chloride and sodium bromide. Using silver nitrate and any other reagents, develop a procedure to extract the sodium bromide. But you react silver nitrate, first of all, acidified so that you do actually get silver chloride and silver bromide, and not something else like silver carbonate, which is also a white precipitate. You get a white precipitate of silver chloride, you get a cream precipitate of silver bromide. You're also going to get some sodium nitrate, NaNO3. That's easy enough to work out that that's what you've got left over. And then the harder question is, how do you get the sodium bromide out when they're both precipitates? AgCl is a white precipitate, AgBr is a cream precipitate. But you should know that if you add dilute ammonia solution, silver chloride dissolves in dilute ammonia solution, whereas silver bromide only dissolves in concentrated ammonia solution. So as long as you use dilute ammonia solution, the silver chloride will dissolve and the AgBr won't dissolve because it's not concentrated ammonia. So you'd add excess of dilute ammonia to a mixture of precipitates and the silver chloride precipitate will dissolve. Incidentally, ammonia reacts with silver chloride to make AgNH3 and Cl minus, something else to learn. And then you've got a precipitate of silver bromide, so what would you do? You'd filter it off, wash it with distilled water to remove any soluble impurities, and then dry it. Write an ionic equation for the reaction between chlorine and sodium hydroxide solutions. This was given in the introduction, also in your booklet. So sodium hydroxide and chlorine make sodium chloride, sodium chlorate 1, where the oxidation state of the Cl is +1, Na +1, Cl +1, O2 minus to leave nothing left over. So that's why it's chlorate 1, used as bleach and to kill bacteria, and water, something else to learn. And then if you take the Na pluses away, you end up with 2 OH minuses, Cl2, Cl minus, ClO minus, and H2O. Give the oxidation state of the chlorine and each of the chlorine-containing ions formed. So in ClO minus, if there's a minus left over and O is 2 minus, then the Cl must be in +1. +1 minus 2 for the oxygen leaves -1 left over, and easy for the oxidation state of the Cl minus. It's on its own there, so the Cl must be in -1.